Okay, problem 5. It's the integration of cosine x to the power of n. Okay, n, it could be 0, 1, 2, it could be any non-negative integers. First, prove the formula is in when n is greater or equal to 2. Right, so let's try to do this integration. Let's put it here. In is the integration of cosine x to the power of n. Obviously, it's 1 times it, so we can use integration by parts. It is, right? But if we do that, we may miss a point because let's see the formula we want to prove. Right, we want to prove it's something like this. So it should contain both sine and cosine. So maybe we should split this. So maybe we should split this integration, right? Like this. It's cosine x times cosine x to the power of n minus 1. Alright, so this part is your use derivative, this part is your v. Okay, let's do it. It's sine x times cosine x to the power of minus 1 minus, okay, so this is u, this is v, minus the integration of sine x times v's derivative, right? It's n minus 1 cosine x to the power of n minus 2 times, okay, now cosine derivative is negative sine. Okay. So this part is your u, this part is your v's derivative. It's sine x cosine x to the power of n minus 1 plus, you can see m minus 1 integration of sine x square cosine x to the power of n minus 1. So now sine x squared is 1 minus cosine x squared, right? So it's 1 minus cosine x squared cosine x to the power of n minus 2. Which means it's n minus 1 integration of cosine x to the power of n minus 2 plus n minus 1 integration of, but here it's a negative sign, right? So minus n minus 1 is the integration of cosine x to the power of n. Okay, so now close to it, right? Close to it. All we have to do is to realize that the left side is always in, right? And this side is also your in, right? In is cosine x to the power of n. So we have to realize in equals this plus n minus 1. Right, you also have to realize this is exactly n minus 2. Right, so n minus 2 minus n minus 1 in. And you can move this to the left. You have in equals this. So you divide by n in the end. And you get the formula. course, n should be greater or equal to 2 when this holds, right? Okay, then part 2, use part A to help you. Part B, use part A to help you quickly solve this integration. For example, cosine x cubed. Right, now realize n is 3, right? So you can sub in 3 here. It should be 1 over 3 sine cosine n minus 1, right? Plus 3 minus 1 over 3 I1, right? What is I1? I1 is just the integration of cosine x. So, with the aid of the formula, we can write down the answer quickly. Okay. Okay. Part 2, cosine x to the power of 4 from 0 to half pi. Right, again, formula is, let me write down here, in is 1 over n cosine n minus 1 sine plus n minus 1 over n in minus 2. So here, realize that your n is 4, right? Your n is 4, which means you could do 1 over 4 cosine x cubed sine x, right, from 0 to half pi plus 4 minus 1 over 4 in minus 2, right? Integration of cosine x squared dx. And for this part, you can use the formula again. Right. For this part, we can do the calculation. It would be, okay, for this part, you just sub in, and it will be 0 minus 0, right? So this part is 0. Just 3 over 4. Now, n is 2. So n is 2, we can do the substitution. It's 1 over 2 cosine x sine x from 0 to half pi plus 2. Right? 2 minus 1 is 1 over 2 in minus 2. In minus 2 is just the integration of cosine x to the power of 0 from 0 to square root pi over 2. Right? And to do this calculation, it's still 0. Okay, this part is still 0, which means it's 3 over 8. Right, this part is 1. So x from 0 to half pi. So the answer is 3 over 16 pi. Okay.